Hello, my name is Emily Herbert, and I was assigned number 20, find multiple sets of polar coordinates for a given point. Well, I had to first find out what a polar point was, or coordinate, sorry. And so I found this from the book, definition. So the foundation of a polar coordinate system is a horizontal ray that extends to the right. So here is an example. Sort of a ray kind of goes towards the right. The ray is called a polar axis, and at the end point is called a pole. A point P in the polar coordinate system is representative of an ordered pair of numbers, r and angle, r and some angle. R is the distance from the pole to P. So it's from the pole, this distance, to this coordinate P. Oops, sorry if I wasn't looking. Alright, and the angle, the second coordinate, or second part of this coordinate P, is the angle from the polar axis. It can be measured in degrees or radians. Positive angles are measured counterclockwise, something we're kind of used to, counterclockwise. And if the angle is negative, it goes clockwise from that polar axis. Alright, so I need to zoom down. So the signs I thought were kind of important to understand as well when it came to polar coordinates. The point P with R is an absolute unit from the pole. So, you know, if it's 1 or negative 1, it's still going to be 1, that distance of 1, 2, 3, whatever. But it's kind of where it matters, if R is greater than 0, the point lies on the terminal side of the angle. By example, here R is 2, the angle is 35, that's where the point is lying. That's where that coordinate is. But if R is less than 0, it lies on the opposite side of the terminal side. So here R is negative 3. So here's 3, goes out 3. That angle is positive, so it's going counterclockwise. And then that point is opposite of that terminal. Sorry, my angle is terrible. Every time I keep looking up. Of the opposite of that terminal side of that angle. Now, if both R and the angle are negative, we go clockwise from that polar axis, and that point lies opposite side of the terminal angle. Good stuff. Okay. Alright, so back to the question. What was it? Find multiple sets of polar coordinates. Okay. So, this is sort of a rule here. In rectangular coordinates, each point y-x has exactly one representative. By contrast, any point in polar coordinates can be represented infinitely many ways. Infinite ways. Why does it say that? Okay, infinite ways. Okay. For example, we can add 2 radians, and it does not change the point of location. Or we could change that positive R, or I guess if it was a negative, we're going to make it positive. And we can add half a radian, not half a radian, but, half a radian. And again, that point location will not change. Or just a radian, 1 radian. Oh, good. All right. And that kind of says it here. Add any 2 radians to any angle and do not change R, or add 1 radian and replace the R with negative, and that point will not change its location. and it says here is kind of a hint, continuing adding 2 radians to either, adding or subtracting 2 radians to either of these representations does not change the point of location. So you remember you can add or subtract. It all kind of depends on, what I figured out later is this interval gives you where that angle is. So I grabbed an example off of the homework because I always find that is a great place to kind of find something. And the question started off with a graph. If you had done this homework, there was several questions leading up until this where it was asking you, it was giving you a coordinate, and it was asking you where to locate it on the graph. You know, here's the representation of it. So here we go. R is 4, and that angle is 1/3 of a radian. So here's 4, and that's about 1/3. Or you can tell there's 12 little hash marks, so I just divided by 3. So here's 1, 2, 3, 4. So that's about 1/3, and it's at this point, this distance R at 4. Now I got that right. That was nice. So it was asking me to find 3 different points with these sort of conditions, these angle conditions, these interval angle conditions. So that's what I did. So here, R is greater than 0. So R remained the same. That was 4. R remained the same. But they wanted that angle to be, wait a minute. They wanted that angle to be, oh my gosh, greater than equal to -2 radians, but less than 0. So that kind of gave me the hint that I need to subtract 2 radians from that original given angle that was given in the coordinate here. So I subtracted, and this is me working it out, and I got -5/3 radians, and that was the point. Now where that brings me, let's see. So 4 brought me out 4, and then because the angle was negative, where was that point? The angle was negative. Negative angles are measured clockwise of the polar axis. So here's 4. We measured it. I already forgot what it was. -5/3. So here we go. 5, -5/3. Boom. Same spot. Okay. 4. But we went this way. We went this clockwise, this negative way, and it brought us here. Brought us to the same point. Sorry if I keep moving my phone around too much. Alright, so this time it asked for 0, or I'm sorry, it asked for R to be less than 0. So we just made it -4. And it asked for that angle to be greater than 0 but less than 2 radians. So you know it's going to fall again. Well, we kind of know it's going to fall somewhere in between here. So this kind of gave me the hint. Since we're changing that R into a negative, I went back to this sort of hint here. If we're going to change that R to a negative, we're going to add that radian. And that's what I did here. I added it. There's me doing the math. And that's the point. I accidentally, I originally subtracted that radian, and I got -2/3. I ignored this interval, but that actually ended me in the same spot because I went -2/3. I was brought over here, and R is -4, brought me to the same spot. Boom. But you can't ignore the interval that it was given. It had to be greater than 0. So I shouldn't have got a negative because that was outside this interval. So it was the same point, but outside what the question was asking for. So be careful. Look at these intervals. I got that wrong in the homework, but you know, I don't get credit for showing my work. Alright, so part C of this question is So the angle is greater than 2 radians, but less than 4. So that just gave me the hint that I'm going to add 2 radians. R staying the same. So no, stay in that 4. I'm not going to have the negative. So here's me doing the math, and that's what I got. And that's more than 2 radians, but less than 4. And I got 4. This is my point. So basically, here's 4, going out 4, and then we go all the way once, and then one more third, and that's where we fall. I will submit this along with my video, because I know I'm scrolling a lot. But all this is from the book. These are great examples from the book here that really helped me. All right, thank you very much.